Welcome. So this question says, how does photon energy relate to photon frequency? So we have, well, photon, let's just picture it. And inside there's a certain frequency. And we have E equals HF. That's energy, and that's frequency. And this is Planck's constant. E is equal to a constant times F. So if I have energy vertically and frequency horizontally, I would get a straight line. So it's going to be linearly. Cool. And then the second question is, using this, what is the energy of a purple photon, which incidentally has a wavelength of 400 nanometers. So here we have a wavelength, and so we have a certain frequency, of course, and that frequency be converted into a wavelength. So we start off with E is equal to HF, but also C is equal to F lambda. So F is equal to C over lambda. So if I combine these, I get E is equal to H C over lambda, which equals, and it turns out that H is equal to 6.6 times 10 to the minus 34 numerically. So this is equal to 6.6 times 10 to the minus 34. And then the speed of light, of course, is 3 times 10 to the 8. And then the wavelength. And the wavelength I gave you was 400 nanometers, which is 400 times 10 to the minus 9 meters. So E is going to equal, if I get my calculator, I get 6.6 second E to the minus 34, enter, times 3 second EE to the 8, enter, divided by 400 second EE to the minus 9, enter. And I'm getting from that 4.95. So this equals, sorry, locating my pen, 4.95 times 10 to the minus 19. Minus 19, and that would be in joules because I'm in SI units. By the way, if I wanted to, I could simply divide that by the charge of one electron divided by 1.6 second EE to the minus 19, and that would give me 3.09. That equals 3.09 electron volts. Two ways of writing down energies. The second way, electron volts, is really convenient because if I take, say, a stream of electrons and I accelerate them through a certain voltage, then I get that number of electron volts. So electrons accelerated through 3 volts would give me 3 electron volts. Through 7 volts would give me 7 electron volts. So it's a very convenient way of keeping track of how much energy there is there. And if I want to figure out, well, what's that in joules, I simply multiply by the charge of an electron, which is 1.6 times 10 to the minus 19. So there we have it.